All right, time to get ready for our Unit 1 test. We got our review here, and Unit 1 is all about lines, segments, and points, and planes, and the basics of geometry. So our first questions here, we have our segment addition postulate. We know that the parts add up to the whole, so simply just start with the parts. One part is 12, one part is 19, and they add up to the whole, which is QS. All right, so we know that QS is the distance from Q to S, and that's what we're asked to find. And so that's going to be 31. Simply that. Next, we have two parts. Again, we've got QS, which is the part we don't know. So QS and the 47. So we know the QS there, whatever that is, plus 47 has to equal the whole, 59. And now we got a simple equation. Just subtract 47, and we know that QS is, what is that, 12. All right. Excellent. Now we got this drawing over here. We're naming an array. Remember, array starts at one point and goes on forever. There's lots of rays here. We can start at C and go on forever through E, so CE. Okay, that's this guy goes like this down through here, all right? Then we've got an array that goes from maybe A up through B. And these guys, by the way, are supposed to have arrows. It's hiding back here, all right? And so we could say AB, lots of rays. Make sure you have the right symbols on top. There's other options. Next, we're looking for the intersection of M and N. So there's two lines. We've got M is the name of this line and N. Remember, points are named with uppercase letters, and when we have a lowercase letter, that represents a line or a variable, all right? So where do these guys intersect? Intersect means where do they touch? That was a bad outline there. There they are right there. They're crossing at point E, okay? So we can say point E, all right? Very good. Now we're going to some more vocabulary here. A little true and false. We want to know, are A, R, and B collinear? So we have A, R, and B. Are they collinear? Well, what does collinear mean? Collinear means on the same line. And so no, these guys are not on the same line. So that's false. Okay, because they're not on the same line. Okay, so not on the same line. Give a good reason, a little justification there, all right? All right, so now the question is, are BW and AT lines? Yeah, that's kind of too easy. BW is a line here, AT is a line, so that is true, all right? And then is BR and RT, are they opposite rays? Well, BR starts at B and goes through R. It's that way. Then RT starts at R and goes through T. Well, they're not even close to opposite rays, so they're going totally different directions, and they don't share an endpoint. So opposite rays have to share an endpoint and go opposite directions, okay? So this just plain has a different endpoints. They got to share the same endpoint and go opposite ways. Plane D could also be called ART. We can name planes with 3 letters or 1 letter if that 1 letter, like D here, is not a point. D is not a point. A, R, and T are points. They're next to dots. Now there's a problem. A, R, and T are on the same line. When you name a plane with 3 letters, you've got to name it with 3 points that are not on the same line. So we have to say false. We can't name it that way because A, R, and T are collinear. You have to pick 3 points that are not collinear. All right? Very good. Now, what about the intersection of AT with plane E? All right, AT is this line, and then plane E is this vertical plane right through here. All right. And where are they touching? Well, they're touching at one point. They're touching at point R. All right? So that's the idea there, okay? And, oh boy, my grid copied kind of crazy here for these next one. So I'm going to approximate it. Let's plot these points, and I'm going to have to approximate. I don't know what happened over here. A little crazy, so, but let's see what we can do. Here's our points. When we graph our points, we get a line like this, or a graph like this. This is, all right, we haven't talked a lot about all these, but this is a quadrilateral. Okay, that won't necessarily be on the test. We'll talk more about that in the future. Or it's really a trapezoid. If you got that, nice job. Okay. And then we want to classify the angles. So angle P and angle Q, nope, angle R, these guys right here are right, are 90 degrees. They're right angles. Okay. And then we got angle Q, this guy right here. This is obtuse. Okay, obtuse means more than 90, and this guy's acute, less than 90, all right? That's how we get a quadrilateral. So, coming over here, so we need to be able to classify the angles tomorrow on the test, okay? And so, you won't necessarily need quadrilateral trapezoid, but you need to know how to classify them. Let's plot these points and see what kind of angles we get. So plotting our points here, we get a triangle. It looks like it might be an equilateral triangle, but hopefully we know it's a triangle at least. And all of these angles are less than 90, so they're all acute angles. All right? Acute means less than 90. Remember, 90 is like the corner of a paper, and that's less than the corner of a paper, okay? I don't know if they're all congruent, but they're all definitely less than 90, all right? Very good. So there's first page of some basics of geometry. Let's continue on. Number 12, we know that AFE is a straight angle here. CFE is right. That's all given to us here, all right? And we want to identify all supplementary and complementary angles, all right? So supplementary adds up to 180, right? So 180, we have lots of pairs here. We got AFB, these guys right here, and BFE. That's one pair. We have another one. We can do AFC. That's this guy here, and its other angle that on the other side that makes up the straight line. Those are supplementary. Then how about this guy right here? So this angle here, and it's supplementary over there. Okay. So we get these three pairs of supplementary angles there. So there's our supplementary angles. Now let's go for some complementary angles. Remember, complementary adds up to 90, all right? They complement each other. So we have some pairs. We've got this angle here and this one. They make 90. Then we've got another pair here right there. Those two guys will add up. That's A, F, B, and BFC. All right, two pairs. Great. Moving on to measuring some angles here. All right, so we want to measure AOB using our protractor. And so we see that AOB, this guy right here, AOB, all right? It's an acute angle starting at 0 here, and we're going 0, 10, 20, 30. So that is a 30-degree angle. So that equals 30 degrees. Next, we have AOD. So that's this guy right here, from A to O to D, AOD. That's this guy right around here. So we're going to start at 0, work our way around, okay? And that's 140. It's kind of hard to see the 1 under there, but there's a 1. 140 looks like 2, so we got 2 little marks there. So that's 142 degrees, all right? And so equals 142 degrees. All right. Next we have BOD. So BOD is going to go from BOD. That's this angle right here. Now this one's pointing at 30. This one's at 142. So to find that distance, we're going to subtract. So this is 142 minus 30, which is 112 degrees. So that's the protractor postulate that says subtract the two angles. EOB is the last one here, and that is E to O to B. Now make sure you read the right numbers. Here we're going, this is on the 0 line. We're going to read the outside because we're climbing 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 140, 150. All right, so make sure you're reading the right ones and stop and think. Should it be obtuse? Well, this is obtuse. This is obtuse. And another obtuse. And an acute angle. Those are the classifications. So we just classify. Classify means what type of angle it is. And what's the relationship between EOB and AOB? So EOB and AOB, well, here's EOB right here, this guy right there. And AOB is this one right here. Okay? They are supplementary. Supplementary adds up to 180. That's okay. Another response is that they are a linear pair. That's actually even better. They're a linear pair because they make a line. So those are two good reasons, okay? Here we got some pairs of angles. All right, now these two are going to add up to 90 because that right there, that means 90 degrees. So the two angles, 3x plus 10 and x plus 10, these add to 90. So we end up with 4x plus 20 equals 90. Subtract 20 from both sides, and you get 70. Divide by 4. Well, half of 70 is 35. Cut that in half, we get 17.5 here. So x is 17.5. So let's plug that back in, and we get 17.5 plus 10. And that's 27.5 for one of our angles here. And this other one, if we subtract 27.5 from 90, we can get this, or we can plug it in. Either way, we're going to get 62.5 degrees, all right, for that angle there. Excellent. So let's go to these guys. These are supplementary. So our two expressions, 3x plus 20 plus 2x minus 5, have to add to 180. Supplementary adds to 180. Let's combine like terms. And 20 minus 5 is 15. Let's subtract 15. And we get 165. If we divide by 5, we get, that gives us 35. So plug that in, we get 2 times 35 is 70. So this comes out to be 65. That doesn't match the drawing very well, but the drawing's just a model, all right? So they probably should be reversed there, okay? So one more here. Now we have two angles. We've got angle ABC. So A, B, C. And we've got D in the middle of it here. We know that the whole ABC is 110. We've got this ABD is 3x plus 15. We've got 7x minus 5 here. So we know 3x plus 15 plus the 7x minus 5 has to be equal to 110. So we combine, that's 10x, and 15 minus 5 is 10. Let's subtract 10, and we get 10x equals 100. And dividing by 10, we see x equals 10. A lot of 10s going on there. All right? And to find, actually just asked to find the value of x here. So we got it, x equals 10. All right, and there you have it. So work hard, and you're going to do great on the test. So keep working.